complex numbers. Complex numbers, real and imaginary, come together with their powers combined. And I don't know if any of you guys know who Captain Planet is, so we'll just stop it right there. But real and imaginary, when they come together, part real, part imaginary is a complex number, because they have the form a plus bi. A is the real, bi is the imaginary, and that's complex numbers. It's just both of them together. And so this is an example. 4 minus 2i is an example of a complex number. Part real, part imaginary. Now when we add these, what we're really doing, or if we subtract them, we're just going to combine the reals and add the imaginaries. Going to be quite simple, actually. So 4 plus 3 plus a negative 4 equals 7 minus 4, or just 3, and negative 2i minus 3i plus 7i. So that's negative 5i plus 2i. It's negative 3. Let's try that again. Negative 5 plus 7 is 2i. And that's where we're at there. 3 plus 2i. So subtraction. The only thing you have to worry about here is that you actually subtract 3 minus 2. And so what I usually do is the same thing I did with polynomials, is I make this negative and this positive. So add a negative and then subtract a negative makes it positive. So negative 2i plus 3i. Just make sure you do that. 3 minus 2 is 1, and negative 2 plus 3 is 1i, or just 1 plus I. Multiplication. Just as simple as it was dealing with x's. So you get 2 times 3. 2 times 3 is 6. 2 times a negative 2i is negative 4i. 5i times 3 is 15i. And 5 times negative 2 is negative 10i squared. Now, we combine like terms, and we get 11i, and we get minus 10i squared. Now the I squared, remember, is negative 1, and so that is really the trick here. Because most of you guys are good at dealing with multiplication and foiling, as you call it. First, outside, inside, last. But take care, don't forget to simplify. Alright, so then 3i and 2i minus 1 squared. And so what I'm going to do is I'm going to write this out. And you're welcome to do either one of these in any order, because this is kind of like multiplying 3 numbers, 2 times 3 times 4. And I can multiply them, and I can do 2 times 3 first, or I can do 3 times 4 first. It doesn't matter. And so what we're going to do is I'm going to multiply 2i times 2i and get 4i squared. And then I get a minus 2i and a minus 2i, so that's minus 4i and plus 1. I'm going to simplify this already, because 4i squared is negative 4, because that's a negative 1. Minus 4i plus 1. So 3i is the same thing as negative 4 plus 1 is negative 3 minus 4i. Negative 3 times 3, negative 9i minus 12i squared. And then we take into account that I squared is negative 1 again. And so negative 12 and negative 1 make a positive 12 minus 9i. Division. Same thing with radicals that we saw is that we can't have an I in the bottom, and so we are still going to multiply by something to cancel out the i's on the bottom, and it's still going to be the conjugate, because it's still going to have its magical powers of eliminating that middle term. So I'm going to add 4i, 2 plus 4i, conjugates. So when you do that, remember that we're multiplying a binomial times a binomial. So 4 times 2 is 8. 4 times 4i is 16i. Negative 3 times 2. And negative 3 times 4 is negative 12i. And on the bottom, we get 4. You get 8i minus 8i. And I'm going to show this, but I'm hardly ever going to write it just because that will always cancel out. Because we set it up to cancel out. And then minus 16i squared. So 8, 16 minus 6 is 10i, and then that's a negative 1. So that's really plus 12. And 4, and that's a negative 1. So that's really plus 16 on the bottom. So if 8 plus 12 is 20, plus 10i over 20. Now, it's going to be very, 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 very tempting to cross out these 20s. But you'd be very wrong. Because if it was 2 plus 3 over 2, 5 halves is not the same as 3 over 1. And so that's why this doesn't work. Instead, if you want to think of pulling out the 20 out of each thing, or looking at what each has, let's split it up. 20 over 20 plus 10 over 20i. So that's 1 plus 1/2 I. And that's very appropriate because you have the real and the imaginary, making up a complex number. So, let's find the reciprocal of 4 plus I. To do that, we are going to usually just flip it over, right? Put it underneath 1. Because that means that, well, that's just how you find reciprocals. Anything times itself, or times its reciprocal is 1, so 1 divided by that reciprocal, 1 divided by that number will find you the reciprocal. We are going to multiply this by the conjugate, like we just did on the last problem. And we get 4 minus I on top, so 1 times anything. And then 16 plus 4i minus 4i cancels out, and then minus I squared. So that's 4 minus I times 4. This is negative 1, so that's really plus 1. So that's 4 minus I over 5. I'd be okay with this. Realize that you also have, you could also distribute that and separate the real from the imaginary. There's a 1 in front of the I, so 4/5 minus 1/5 I. And that is how you do complex numbers. Now, I probably shouldn't show you this, but our calculator is capable of this if you ever need it. One thing you want to do is make sure in mode that you have it set to be able to use A plus BI. Otherwise it'll give you errors. The second thing you need to know is that above the decimal sign here there's an I. And I'm just going to double check our 2 plus 5i. So hit the second button and then the decimal, and 3 minus 2i. 16 plus 11i. And there you have it. Complex numbers.